Hi and welcome to our demo to show Kotlin running with Spark Framework and WebSockets to produce a web chat demonstration. This should be a fairly quick and simple demo, so we'll code as we go, and any questions please feel free to leave them in the comments and we'll get back to you. Okay, so first off, we're using IntelliJ. Let's create a new Maven project. We will put in a group ID and call it Kotlin WS Chat. And there we go. Okay, so first things first, we'll enable auto imports, and then we also want to configure Kotlin in this project. So we click on Tools, Kotlin, Configure Kotlin in Project. I'm using 1.1.3-2 and it's brought in 2 Kotlin dependencies and also created some build plugins. Okay, so that's Kotlin configured. However, we need Spark also, so we'll create a dependency. The group ID is com.SparkJava, and the version we will be using is 2.5.4. We'll be using Spark Core. Okay, let's use 2.5.5. We'll also be using JSON as part of this, so we'll go for com.fasterxml.jackson.module. The artifact ID is Jackson module Kotlin. And the version we will be using is 2.8.4. And the final dependency that we will want to bring in is SLF4J. Would have got errors if we hadn't done this. It wouldn't have affected the running, but it's useful to see the outputs. So we'll be using 1.7.22 for this. Okay, we'll save that, and that is our Maven setup and running, and imports are all done because we set up auto import. Okay, so now let's create our Kotlin file for our chat controller. So first off, actually, let's create a package. Best practice to do that. I'll move that into there. Okay. So, first things first, we should import Spark. And we'll create our main function. Okay. Now, I prefer to run my web stuff on port 9000, so by default Spark runs on 4567, so port 9000 here just changes that default to 9000. We'll also be doing some HTML work here, so we will explicitly say that we want our static data to be read from /public. So we can go ahead, move to here, and create a new directory called public. And we've now got something here where we can put our HTML files. I'll not put anything in there quite yet because it will show a quick demo in a second. Now, for those who've not used the Spark framework before, if I briefly show you what it looks like. They've got a Kotlin DSL. We won't be using that today because it doesn't support WebSockets, so we'll be using the standard Java, although there's some additional nice bits here. So it basically is very expressive. You use the HTTP verb the path you want to be sending it to, and then the request response. So I'll show you how this would look in a Kotlin version now. So simply we can say /hello, and then rather than have this inside of the braces, because Kotlin allows us to, if the final expression is a lambda, we can put it inside of some body tags. So hello world. So let's just run, we'll run that, and I can show you this working. Okay, all fine, up and running. So let's go to localhost port 9000, and we didn't find anything because I went to the root. So if I go to hello, you'll see hello world. Now if we go back to our code, and here I create a new HTML file called index, and we'll call this chat WebSocket Kotlin as our title, and in here I will just put a paragraph tag and say ready for WebSocket chat. Save that, restart. Now I have to restart here because it's inside of the WAR file when it's generated. There is a way here where instead of using static file location, we could use static external static file location. We therefore wouldn't have to restart because it's being read outside of the WAR file. But for packaging purposes, this is a little bit nicer, so we'll leave it as is. So now that we have restarted that and I've specified an index HTML, if I go to the root, whereas I got 404 last time, now I'm getting our index page that we set up. Okay, great. However, we're not doing traditional SparkJava work. We're going to be working with WebSockets instead. Now, WebSockets are different to the normal way of working, because they offer a number of different activities within a single HTTP path variable. So, how this works in Spark is that you specify the path you want to talk to. So in our case, we'll call it chat, but then we need to specify a handler to deal with this workload. So we'll call it chat WebSocket handler, and we have to pass in the class rather than an actual object. We're passing in the class name for it. So we use the Kotlin methodology for that. So the other thing to note with WebSockets is in Spark, when you use the verbs, the get verbs, it will automatically get the server ready, up and running. With using the WebSocket, we have to tell it to initialize. If we also used a mixture of the verbs and the WebSockets, then the initialization would happen automatically. WebSocket also has to come before any of these get, delete, post verbs also. But we're not going to be using those today, so we'll just do initialize and WebSockets. So great. Okay, so now let's start to implement that WebSocket handler that we specified just up here. So create a new class, call it chat WS handler, and we have to specify that this is a WebSocket. There we go. So that's imported. We'll change this import to be a star because we'll be importing a number of annotations from the Jetty WebSocket API. Now there are a number of different methods that can be called as part of the WebSocket handling. So we've as we go to on, you can see here we've got on WebSocket message, on WebSocket connect, close, error, and frame. The ones that are important for us today is message and close. What we can also do, just so you can see it happening, we'll do on connect as well, and call it function connected. Now that passes in a session, which you can see up here has been imported, API session, but all we're going to do with that, just to show you it happening, is to say session connected. We won't do anything more. We don't need to do anything more with that. We'll just leave it there just so that you can see it happening. Okay, now we'll move on to the close at this stage. So we'll call it disconnect. Create a new function called disconnect. Now that passes in a session. It also passes in a code which is an int, and it also potentially passes in a reason. So reason can be null. This is coming from the Java API, remember. So we have to put a question mark here because it is a nullable value. This did catch me out the first time, so hopefully being explicit about this helps you out as well. Now what we want to do here when the session disconnects is that we will want to remove the user from our list, and then we want to notify all other users this user has disconnected. But right now we don't have users and we don't have lists, so we will come back to that in a second. So instead we'll now carry on with the on WebSocket message. So this is the bulk of our work. So and when I say bulk, it's not very much at all, but it's certainly more than a couple of lines of code, which is the other ones we have. So a message comes with a session. So this is the session that sent the message through, and it comes with a message string, so we will call that string message. Now when we get to our HTML in a second, what we will do is to specify that the message string that we send back and forth will be JSON, which is why we imported Jackson earlier. So first things first, let's convert that message to a JSON. So we'll use Object Mapper for that. So create a new Object Mapper instance. We will read tree and pass in the message. So that will just create a simple JSON object structure for us to be working with. Now the JSON that we will configure will be in the following format. It will be of a type, and that type can be a join message or a say message, allowing us to say I've joined, or the chat message that we send back and forth. And then it will contain some data, and that data will be the name of the user who is requesting to join, or the chat message that we're passing back. So that data is essentially just going to be a string, but it will be a name or message. So given that we've got two types of message that we want to deal with, we'll use the Kotlin when clause to deal with this. So from the JSON we will say get type, and then that is of type text, and we will then deal with that message. So as I said, we have join and we have say. Okay, so first of all let's deal with the join message. So This is assuming that the user has connected the WebSocket. We will ask them to enter we'll set up an input alert box that will ask them to enter their user or their chat name. So we'll send that through. So we expect simply a name coming through as part of it. So what we want is, we'll say the name equals JSON.get data, in this case, because it's the second part of our JSON string that we talked about above, as text. So simple and fine. Now what we want to do is we want to put this user into a list of users, so that we know everyone who's in our chat room. So we don't have a list of users, or a list to store these users, and we don't have a class to hold the user either. So let's go up here and create a user object. Now we could create this as a data class. I don't need the toString method or the other bits and pieces that this gives us. I just need a simple object. So we will create an ID of type long, and then a val to store the name, which is a string. Both of them are non-null values. And now we need somewhere to store these users. So we'll call this list of users, and we'll store it in a hash map. Now, as you've seen, we get sessions coming through, and that's the link to the users. So we'll have our key will be a session, and the value will be user, and all done. Now, one of the other things that when we set up the user, as you can see up here, we require an ID. So to increment the IDs, we'll use an atomic int. So I'll create a new var this time, because it's a changing variable, and we'll call that atomic long, and we'll start base of 0. Okay, so let's create our user. So we'll say users.put. The session is our key, and our value will be user. So first off, we need an ID. So from the IDs we will get and increment. So that will get the value, increment it on, and then ready for the next user to come through. But then we also need the name, so we will pass in name. Now, we're not going to use name again, so just a slight refactor. Now that you can see it and it's all clear, I will just slot this in there, just to keep it nice and tidy. Okay, the next thing we need to do, so we've created the user, so therefore they have joined our list of chat room users, but we need to do two things. First of all, we need to tell this user about all other users, and we need to tell all other users about this user. And the reason why we do that separately, we could just send a broadcast out to say new list and send it to everybody, but in a big chat room, every time someone joined, if we had to send the entire list out again, that would be very wasteful. Easier, yes, but wasteful. So what we will do is we will send two separate messages. So first off, we will call emit. Now emit will be just a single message to a single person. So we want emit to this session, and we want to tell them who the users are. So we'll create a message object. We'll call the message that we're message type users, and the values that we send is users.values, and so that will send all the users through. However, we don't have a class called message yet, so we will pop up here and create it. So message will be a val of message type, which is of type string, and then the data that we're passing across. And now this can be any. So in this instance here, we will be sending a list of user objects, but in the next the next piece, where we tell all other users about this only user, we will only want to send a single user object, hence the need for any rather than some specifics. In other types of message we will see is the broadcast of the chat message. So again, we could in this instance just use a list of one and a list of many, but we will also need chat as well, so any is the right data type here. So what we need to do now, so it's, let's say, tell all other users about this user. So what we want to do is broadcast to others, and we will pass in the session of whom we do not want to broadcast to, and we will create a message called message type is join, and the message object is the user who has just joined. So we didn't keep hold of the user up here, so let's refactor this slightly. Okay, so we've now created the user, we'll store it here, and then we'll reuse it here. Okay, so that's everything we need to do here, except we haven't created the emit and the broadcast, but we'll come back to that in a moment, because we've got our final method to do, which is to say when somebody says something. Now this one will be a simple broadcast to everybody. So when a user sends a message, they will send it to the server and it will broadcast to everyone, including themselves. So the list of chat messages that come through, they won't ever update their local data. It will all be pushed down from the server, which is why we're doing a broadcast rather than just a broadcast to others. Now what we're doing here in the broadcast is to say, and what we want to say is whatever they have said in the message from that we've received in our JSON up the top here. So we will send a message to everyone with the type say and the data as they've said. So before we finish the message function, what I will do, just so that you can see everything on the server side as well as the client side, is we'll do a print line, and I'll say JSON message is the message that got passed through here, so we'll be able to see everything that comes through. Okay, now that we've got our users hash map, and we've got our emit, broadcast, and broadcast to others and broadcast, then we can just finish off our method here. So remove the user from our list is a fairly simple. The user we're removing equals users dot remove, and pass in the session, and then finally if user is not equal to null, because it could be, there's no guarantees, this is the Java list. Now we're pretty sure that it won't be, so I could use the constructor, but let's do safe programming here. So what I'll do is I will broadcast to everybody, and now that's everybody left, because the user who's left won't now get this message, and we'll say left, and we'll pass the user object through. So that's all done. Okay, so we're almost there on the server side, so we've just got a few small pieces to do just to make sure that we can emit, broadcast to others, and broadcast. So let's create this function emit here. I'll take this down the bottom to keep it tidy. Okay, so I can stick this on a single line, so we'll do equals rather than a method body. And it's simple as the session object has a remote, and we want to send a string, and the string is simply the message object that is sent as a JSON object. So again, we'll go back to the Jackson object mapper, and we will write value as string, and we will pass in the message. Great, so now we can emit to a single user. So given that we can emit to a single user, we can easily emit to everyone. We'll not make that private, doesn't really matter. So let's implement broadcast. Here we go. Take that down the bottom as well. Okay, and again we can get this on a single line, so I will just put the equal sign in. So again, this one is pretty easy actually. So what we're doing here, we want to iterate through our list. So we'll go for a for each, and inside of the method body, all we're doing is simply emitting to every session in that list. So from the iterator, we want to get the key, and we want to pass in the message that we're sending to every user. So again, fairly easy. Now the broadcast to others is basically the same thing with a filter. So we essentially will broadcast to everyone, but we'll do a quick check to make sure that it isn't the user we do not want to broadcast to. So from the users, we will do a filter, and we'll say the key, the key from the iterator is not equal to session. Oh, sorry, that's because I've forgotten to include the session in here. Okay. So we will broadcast, so where not session, we then want to do a for each, and the for each is as simple as what we did previously. So emit iterator.key and pass in the message, and done. So 3 simple socket communications. We are dealing with a few messages, and we're dealing with disconnects. So that's our server side all done, up and running, ready to go. Now this doesn't do anything at all because we don't have anything on our client side. So let's rectify that first. So we'll start by putting some helpers up at the top. I copy this stuff over. So all we've got here, using Bootstrap to help it look a little bit nicer, and then I'm going to use jQuery here as well, just to help a little bit with the updating the data. Now I could use something like Angular or Vue.js, etc. It would be easier, in all honesty, if I used those things, but I wanted to focus specifically here on the WebSocket functionality. So trying to take out all other frameworks, and jQuery is such a minimalistic framework for what we need, it doesn't cause us a big deal. Okay, so let's just change the body slightly because I want to use the full height, just to make sure it looks okay. We will get rid of that we added earlier. Now I'm going to copy and paste a little bit of code here. Essentially, I've got a div that contains two other divs, so two rows. The first row is the chat box and the user list, and the user list is an unordered list with nothing in it at the moment. Let's take that there. And then the second row is just a single element, has the text box and then another bit on the side for the send button. So fairly straightforward, but now comes the interesting part. So let's create a script tag. Again, we could put all this in a separate script tag if we wanted to, but let's keep it simple. So WebSocket functionality. We will start off by actually getting hold of our WebSocket, and so new WebSocket. Now this should be compatible with most browsers as of today. A while back this would have been quite tricky, and using something, a shim over the top of it that allowed long polling and Flash to put shims to make this work aren't as necessary as they used to be. So most major browser vendors now support sockets, which is great. Now I could have hard-coded all of this because I know we're running on port 90, I know I'm running on localhost, but this is good practice. So if we then change the port for whatever reason, or we then want to push this to production, we don't have to change any of our code. So I'll not take the shortcut here just in case it causes you guys problems further down the line. So we have similar types of functions that we had on the server side. So the WebSocket can receive messages. It can have the WebSocket closed on it. The server could close the socket, or the WebSocket can also have an on-open methodology. So let's go for, well, I'll put them all in to start with. WebSocket.onClose and WebSocket.onOpen. Okay, so function. So on message will receive a message. Let's stick this on one line. So we will say receive, can't spell, receive message. Let's make it shorter. And then we are going to receive JSON. So if you remember, if we go back to our chat controller, let's minimize this. We will broadcast, if we call it comes down to emit, the emit is broadcasting a JSON object. So in here we need to be expecting to receive a JSON object. So it's coming through as a string, so we will say JSON.parse, and the WebSocket API, when it receives it as an object which contains data. So don't confuse this with the data that we sent. This is the data from the WebSocket API. Okay, so that's that. Fine. We'll come back to that in a second. So on close, we are not intending to do a great deal with this. Oh, sorry, there's no message. So we'll just put out an alert, and I'll show you this working before we finish the demo, which just says server disconnected you. Okay, now on open, this one's slightly more involved. The most involved is the receive message, which is why I put that into a separate function called receive message, so we'll come on to that in a second. So what we want here is we need to get a name from the user. So while name is equal to the empty string, as we've just set, then we will continue to ask them to give us a name. So we'll just use the JavaScript, the browser prompt function. There's no need to make it more complex for ourselves at this stage. Okay, and then when we have that, we want to send a message to the server to say, I want to join, and this is my name. So this is the first interaction that we expect to have with the server once we've created our WebSocket. So that will directly call the on message, join, and we'll try and get the user's name from here. We haven't, so we'll fill in the send message function next, so you can see that working. So function send message, and we pass in type and data. Okay, so if the data is not equal to the empty string, then we want to, from the WebSocket that we have, we want to send a message, so we want to do json.stringify, and the type of the message is type, and the data is the data. So that will go to the server in the format that we want. Now, the first time we'll call this send messages when the user joins, but we will also use this every time they enter a message in the text box. So what we will also do, and the text box we've called MSG up here. So what I'm also going to do is to clear that value. Now, this seems odd, but it does ensure that value is empty, so it's useful anyway. The other thing that I want to do is to give focus back to it, so if they click off to click the enter button with the mouse, then the focus will go back to the message box as well. So that's that done. So the only other thing we need to do before we get on to the receive message piece is to allow ourselves to send a message to that text box. So there are two ways that we want to be able to send a message. The first one is if we, that should be in quotes, if someone clicks the send button. So we'll just do a simple click function, and then we will call the send message, and in this case we want to say, because that's what we agreed we would use from the server side, and the value that we're sending in our say is the value from the message box. So we want to get the value, and that's that. And again, we don't have to worry about clearing that the text box, because we have already done that. So the second method of being able to send data is if they just press enter within the text area. So it's not absolutely necessary, but as a user you probably expect this. So We'll put a message on key press. We'll take a function of okay, so if the event which equals 13, 13 being the ASCII key for the enter button, the event key, sorry, for the enter button, we will do exactly the same. We will say send a message as our message type. Now we could do this if we wanted to. The other way of doing this, because we already have access to the event object, which is the message box, we can just do e.target.value. So I'll leave both methods on there. Normally I would try to stick to one method to make it cleaner, but I'll leave both on there so that you guys can see that there are two different ways and you can pick and choose which works for you. Okay, so let's go to our function, the only function that we haven't implemented, which is receive message, which takes in a message. Now here we just need a bunch of if statements. So if message.message type, because that's what we used on the server side, double equals say. So if someone has said something, then what we want to do is we want to get hold of the chat box, which is this, the ID for our big chat text area here, and we want to append. Let's put a p tag here. Get the message.data, which will be the message that they send, and close off the p tag. And that's it. Nice and simple. Now, second message we're likely to receive is if a user joins. So let's go for that. So if message type, typing message.message type makes me wish I was back in Kotlin doing using the when clause. So let's do join. Now we will also have another method where we send through all the users, and we'll duplicate this line of code. So what I'm going to do is create a new function called add user and pass in the message data, and I'll break out this function and create a new one called add user and user, and here I'm going to get hold of the user list, which is right up here, the user list. So grab hold of the user list, and again we'll use append here, create a list item. Now I want to I need to keep access of the ID of this user I'm going to add, because I will want to be able to remove users as well when they leave. So the ID I will do is to say user dash and then the user.id, which is the ID that came through in the JSON when we sent the user object. So let's close off that ID and close off the first part of the list item, and now we want to inside the list item tag we want to put the user name, so user.name, and then we want to close the list item, and done. Okay, so now we've got the add user function, we can also do the users. So this is when you first join the chat. It sends you a list of all users currently in the chat. So we will say message.data.for each. So the message.data is a list of all users, so for each will allow us to iterate through each of those users. And we'll say function, call it element, EL for short, and then we'll say add user EL, and that's fine. And then we want to close off that function. Okay, so that's that done, and now our final one to finish is to see when the user leaves. So message.messageType equals left, and we will say, so remembering the format that I used here, so it was #user dash, and then we need the ID, so message.data.id, and we simply want to remove that element using jQuery, and so that should get rid of the user from it. As I said, if we did this through something like Vue.js or Angular, which we just maintain the list and it just does all the watching and updating for us, this would all be a lot easier. I wouldn't have to mess around with IDs, or those frameworks would deal with all that for us, but you get the idea. Okay, so let's save that and let's give it a whirl, see how we get on. So first of all, let's run our code. Okay, we're up and running, so let's go to localhost port 9000. So we didn't get what I expected to, so we didn't connect here, so let's just have a look at our JavaScript console to see what we is going wrong. Developer tools, let's reload it as well, so console. Okay, so line 41 we've got a missing open bracket after. Line 41. Okay, so simple mistake, got a colon instead of a dot. And that's me just being used to using colons for port numbers. So let's go back to here, restart, and line 81. Okay, so this should be one of those, double quote instead of a single quote. So that's fine. So let's go back and see where we get to this time. Yay, okay, so let's close this down, and let's say hello, and so the message has popped up saying hello. So if we go to our server side, we can see that the session connected, we had a join message, and then we had hello message. So the session connected was because we kept this here, even though it's superfluous, and then we had two messages came through, one to say join and one to say say. Now we didn't get the all other users because there were no other users in the at this stage. Oh, sorry, no. So this got sent to the client. So if you if I put network on here, and let's start that again. what we should see. Where's XHS? Not sure. Okay. Anyway, let's close that down. Now that's interesting, but not particularly interesting, given that a chat is meant to be two-way. So let's open a second and say log. Now this time you can see two of us are here. So let's run these two side by side. Actually, let's open a third. We'll run all three side by side. So this one, go back to local host 1000 and say Fred. Okay, so you can see this comes across to all at the same time. So this tiling is just part of Vivaldi. If you're not using Vivaldi, it's a great browser, really useful for this type of thing. So this one is Fred. Hello, I am Fred. And you can see that got broadcast to everyone. Hi Fred. And now Bob will say, I need to leave. See you. And then we can close Fred down. And you can see, oh, it wasn't Fred, it was Wayne. So you can now see only 2 users left and only 1 user left. So our demo worked perfectly. We had all the messages came through and we could send back to the client side the data that we needed to send through to keep all of our objects up to date. So all being pushed through to the server. So there you have it. I will save all this up to GitHub and share the code so that you can explore further and go do more with it. But that essentially is it. A very simple chat controller using Maven to set ourselves all up, Jackson, SparkJava essentially, and Kotlin doing all the great stuff for us. Have any questions, have any feedback, really appreciate it. Put it in the comment section below, and thank you very much for listening.